Here in this video, we would like to talk about principle of calorimetry, or what happens when we mix two different materials who are at different temperatures. What I mean to say is, imagine there is a liquid whose mass is m1, whose specific heat is s1, whose temperature is T1. Let's imagine there is another liquid who is a different liquid whose mass is m2, specific heat is s2, temperature is T2, in such a way that just assume that T2 is greater than T1. When these two are mixed with each other, you will get a new temperature X. What is the value of that temperature? We can find out using the principle of calorimetry. That's the point that we would like to talk. So what is the principle of calorimetry says is, when there is no loss of heat energy in any ways for any reasons, when you mix two bodies and when you mix two fluids or two bodies, heat lost by the hot body obviously lose the heat, is the heat gained by the cold body gains the heat. So when you mix these two bodies, heat body will always lose the heat energy and cold body will always gain the heat energy. According to law of conservation of heat energy, when there is no transmission loss, heat lost by the hot body is equal to heat gained by the cold body. That is called principle of calorimetry. So if you observe this above case carefully, here T2 is more, so this is the hot body. T1 is less, this is the cold body. So this will lose the heat, this will gain the heat. So I can say heat lost by the hot body equal to heat gained by the cold body. Applying that principle, heat lost by hot body is gained by cold body. Here if you notice carefully, there is no change of state. Both of them are going to remain in the same state. As they are going to remain in the same state, we shall use the definition of specific heat as amount of heat required to convert unit mass of substance to raise the temperature of unit mass of substance by 1 degree centigrade. So heat lost or heat gained can be found using a formula msgt or ms delta T. So what is heat lost by the hot body is mass of the hot body m2, specific heat of the hot body S2. You will get a resultant temperature X. How is the temperature will be? As T2 is greater than T1, X will be in such a way that X is greater than T1 but less than T2. I will get a temperature somewhere intermediate between this T1 and T2, which is this is X is greater than that of T1 but less than that of T2, obviously, right? So ms delta T for the hot body heat loss temperature lost is T2 to X. It will down its temperature to a value of X. Heat gained by the cold body is mass m1, specific heat s1. Its temperature increases from where to where? T1 to X. So the temperature difference is X minus T1. This is principle of calorimetry. Let us simplify this further. M2 S2 T2 minus M2 S2 X equal to M1 S1 X minus M1 S1 T1. Take this X term to the other side. M1 S1 X, this minus on the other side becomes plus M2 S2 X equal to, get this T1 term to this side, that becomes a plus here, M1 S1 T1, and this is also plus M2 S2 T2. That implies the value of, so I can write, if I take X common in both of them, M1 S1 plus M2 S2 equal to whatever is remaining on the other side, M1 S1 T1 M2 S2 T2. That implies we can find the resultant temperature using a formula X equal to M1 S1 T1 M2 S2 T2 by M1 S1 plus M2 S2. Here I want you to be careful and understand what these are all, right? M1 is mass of the first one, M2 is mass of the second one, S1 is specific heat of the first body, S2 is specific heat of the second body, T1 is temperature of the first body, T2 is temperature of the second body in such a way that T2 is greater than T1. So principle of calorimetry tells you that when there is no loss of heat, heat lost by a hot body equal to heat gained by cold body. That's the most important part, based on which we can find resultant temperatures of two bodies when they are mixed. That's it. Thank you for watching.